Welcome to free GAMSAT webinar 8. It's the first GAMSAT webinar before the September GAMSAT, so it's getting the ball rolling of the series. Sorry, so our first webinar of the series before you get a September GAMSAT. It has been a month since the March GAMSAT, with results anticipated for release at the end of May, so next month. Hopefully we don't have the same issue as last year when I know a lot of students were waiting, or candidates were waiting for their GAMSAT results. I think ASA said in November, and they ended up coming out in late November. So generally, in years gone by, the March GAMSAT results are pretty consistent. They come out at the same time. They usually come out just before deadlines, submissions for GEMSAS, which is May 31st. So somewhere just before May 31st, you should receive your GAMSAT results. And the reason why they do this is so it gives you a chance to possibly use your March 2023 result for admissions for 2024. Now, if you would like to discuss your GAMSAT score and prospects for entry, you are welcome to contact IME for a free confidential consult. I know a lot of students have reached out to me recently as well, in terms of putting together some sort of study plan for the September GAMSAT. Now's the time to start thinking about your preparation for the September GAMSAT, because you do have about 5 months. So there's plenty of time now to improve for the next exam. So medical school entry guides for medicine entry are now available. So you can access them via the GEMSAS webpage or via University of Sydney and Flinders University. I think it's Flinders. Their admissions requirements don't come out until the end of May. So you might have to wait for that one if you are in South Australia, or if you're interested in attending Flinders. But a notable change for medicine entry in 2024 is that Notre Dame, Sydney and Fremantle do not accept portfolios for entry anymore. What they have replaced portfolios is with the CASPA situational judgment test and bonus points for higher degree research, such as PhD or Masters by Research or rurality. So that's one of the biggest changes. Since last year, I think most of the entry requirements are similar in terms of GPA requirements, say for COVID GPA requirements and interview. So they're all very, very similar. The good thing is I've trawled through all the admissions guidelines for all the universities. So there's 12 GAMSAT universities currently, postgraduate universities in Australia. And I have also looked at the UK and Ireland as well. And we've summarized all of this information in, I think, 4 downloadable documents. You can find that on our website at imemedical.com under the GAMSAT tab. So that's those who are on the mailing list would have received the 4 PDFs. But if you're not on the mailing list, you can just go on our website and access the documents there. I will send again in the follow-up email from this webinar the details for how to access those. I guess you can call them cheat sheets for admissions entry in 2024. It's not just for medicine as well, also dentistry and optometry. So dentistry and optometry at University of Melbourne does require a GAMSAT score. You've got other universities that do dentistry as well. I think University of Western Australia. There's quite a few actually that don't require GAMSAT, because you might have to go through the UCAT pathway. That's the Griffith University. I think UQ. I think UNSW, DWA. Don't quote me on this, but there's a lot of pathways, and I have summarized this as well, actually, that you can access via our website as well. So all the Australian Medical School market, you can access a downloadable PDF with clickable links and hyperlinks to all the schools that offer medicine, optometry and dentistry in Australia, and you can find out all the information through there. Today's session, we will focus more on poetic device, and we'll go for section 1, and then we'll go into chemistry in visual form for section 3. The idea of today's webinar was just to, get the ball rolling, just get everybody back up to speed, because the GAMSAT isn't for another 5 months. I know a lot of students and candidates would have come out of mid-semester breaks at university, having your mid-semester exams as well, coming up this week and next week. It depends if you're doing semesters or trimesters, but also a happy Eid to all those celebrating. And it was a busy April as well with Ramadan. We had Passover, we had Easter, we have Anzac Day next week. And we also have in Queensland Labor Day. So April tends to be the public holiday month. And I know a lot of you would probably still be getting back into uni and getting back into the grind. So the good thing is today, we'll just look at a poetic device and then just studying some chemistry in say a figure. So these webinars, just before we move on, these webinars are recorded and you will receive a link to access this and previous sessions via our mailing list. Otherwise, you can find the videos on our website or on YouTube if you search at IME Medical or Institute of Medical Education. Cool. So just a reminder, you can access our material. We have lots and lots of great resources for GAMSAT, not just GAMSAT, but if you're also interested in interviews or UK or anything related to medicine entry, we can help you out. Just go on our website, imemedical.com. You can find out more free material and other material, other programs we offer. If you search Institute of Medical Education at Facebook, YouTube, and LinkedIn, as I said earlier, you can access the cheat sheets for admissions entry in 2024, but also free GAMSAT exam, free Section 2 essay generator, interview prompts. So there's a bunch of free stuff there. And if you want something more substantive, you can enroll in one of our programs. So we have different programs for medicine entry, and now is probably the time to think about this because you have 5 months and you can definitely build up a profile so you can score well in the September GAMSAT. For those who are in Queensland, if you're in the Gold Coast, you can come visit us at 192 Ashmore Road and come say hi if you would like to rather see us in person. Okay, so today's session, we're going to look at a poetic device and give you a question, a very standard GAMSAT style question that you should expect for those who haven't sat the GAMSAT, how the poetic device questions are usually thrown at candidates. And then next, another chemistry, a Section 3 stimulus that, again, very standard GAMSAT stimuli, where you get given, say, whether it's chemistry, physics, biology, in, say, a graphical form, and you have to utilize some prerequisite knowledge to answer the questions presented in the stimulus. And finally, address your questions. I did receive, I can address them now, actually, a lot of questions from candidates and students in the last month since our last webinar. I think the majority of the questions were based on entry into medicine for 2024. If you do want support, because it is hard deciding on schools, because in the past I've seen students with very competitive GAMSAT scores and GPA scores not get an offer for an interview, not because they weren't competitive enough. I think it's because with, say, for example, GAMSAT's application, you get to pick 5 or 6, you rank 5 or 6 schools who you would like to study at. And based on who you put at the top, which school you put at the top, depends on the algorithm, I guess, spews out which school you're going to get chosen to get an interview for. So picking the right school might actually get you over the line for interview offers. So I can help you with that. If you just want to contact me, we can definitely work through that together. Another question was obviously what to do now, considering Notre Dame got rid of portfolio. How do I prepare for CASPA? Situational judgment test. What is a situational judgment test? You can just go on Google, just type in CASPA, SJT. You can have a browse on their website and see what they're all about. But the idea is, I think it's an hour and a half exam. and you get presented with real life situations and how you would deal with this real life situation. I think it's definitely a step in the right direction for Notre Dame, because there always was the saying, I guess, that Notre Dame would favor candidates who were definitely better off, because if you're going to have a portfolio, it means if you're going to have a very decent portfolio, generally the argument is, this isn't my argument, but the argument is that those who have a better portfolio were more likely to be in higher socioeconomic backgrounds because they had time to do the extracurricular activities, as opposed to somebody who didn't, who was working and didn't have time to do this. So look, the situational judgment test is definitely needed, it's definitely warranted. It's not new. University of Wollongong has employed this for a while now. I mean, in complement with the portfolio, but you can prepare just by, I think the best advice I can give for a situation judgment test is, remember, you're applying to be a doctor. Try to understand what qualities are required to be a doctor, and try to translate that into how you would answer the ethical questions, if you want, the situations you're presented with in the exam. So that's the best advice I can give. Always remember, same thing with interviews. It's the same principle. The schools are trying to assess whether or not you'd be a great candidate to be a doctor. So when you're doing interviews as well, try to answer questions. It might be even a left field question about how would you respond if somebody is trying to teach you how to cut an apple, but they're doing it very poorly. Remember, you don't want to, so you have to treat it as if, I always look at it, if someone's trying to teach you how to cut an apple and they're doing it poorly, think of them as being a patient who's not doing a simple instruction that you've asked them to do. How would you react in this situation? Remember, you have to show empathy. You have to show a moral agency, right? You have to show some sort of ethical principles that you have to understand that they might not be there. They might not have the capacity. You might have to walk them through, be nice, be understanding, try to help, try to give the right information, try to give information on how to cut an apple, try to tell them very simple information, easy to understand. So the same idea with your interview and the situational judgment test. So just keep that in mind. And when it comes to bonus points for high degree research and rurality, if you've done a master's by research and PhD, you'll get, I think it's upwards of 10. So it's 30%. So for interview offers, it's 30% GAMSAT, 30% GPA, 30% CASPER score, and 10% your bonus points for high degree research or rurality. So keep that in mind. If you're not somebody who, I mean, you know what? It actually makes it easier now to apply, because a lot of people would just cancel out Notre Dame because they're like, I don't have a portfolio. Now's the chance to give Notre Dame a go. So think about that. And generally, the question was just about designing study plans. And if you would like to design a study plan, please email me, contact me, let me know. We can work through it together, because with the students in the past, it's definitely given them some sort of framework to build on. Okay, cool. So let's begin with our first section. So section 1, poetic devices. So I've got one question today, just to get you thinking about poetic devices. I always tell students when it comes to learning about literary devices, poetic devices, because a lot of students say, I can't prepare for section 1, it's impossible. There's just so many random words I don't know the definitions of. I mean, you could just say that and be like, well, okay, true, they might chuck a random word from a dictionary of 1 billion words, but giving up isn't going to help. If you just keep chipping away, have like a file or a document with all these poetic device terms and their definitions and examples of each device, you can definitely do well in section 1 when you do get presented a question like this. Now, I've started off with a rhetorical term or a literary device called, I think it's zeugma. Sorry if I butchered that. I think its origins come from Greek and Latin. But there's multiple definitions here. What I'll do before I get into it, you can give yourself about, so GAMSAT section 1, how long is it? So you get, I think it's 62 minutes, 47 questions. I can't remember exactly. I think it is 47, 62 minutes. But the idea is you get, it's about a minute and a half, a minute 40 seconds per question. So this stimulus has one question, so you should be spending about a minute 40 on this question. I mean, it doesn't mean every question is a minute 40, but it just gives you some sort of guide. Give yourself a minute 40. You can pause the screen, and then we'll go through the answers together. But just try to have a think. If you don't know the answer, the good thing about ASA, GAMSAT, you know, when I designed this question as well, you should know enough from the stimulus to be able, if you read the stimulus properly, you should get enough information out of the stimulus to answer the question. So I'll give you a minute 40. So you just want to pause the screen. And then when I start, I'll put my hand down to count down to 1, then we'll go. So your time, so you can pause the screen, but my 5 seconds is going to go now. Okay, cool. So with GAMSAT stimuli, the idea is they should give you enough information that you might have to use some prerequisite knowledge to answer, but the answer should be buried in there somewhere. So a zeugma, a zeugma or a zeugma, it can be defined in several ways. When I wrote this question, I think zeugma has probably 5, 10 different definitions. I picked 2 because let's just walk through the question and make sure that we can at least understand what it's trying to say. But you never know, ASA might design a question where it gives you 5 different definitions, and you had to consider the other figures of speech. But the idea is they're giving you 2 different definitions of zeugma. The first one is a single word or phrase that joins 2 different parts of a sentence, and it must be understood differently in relation to each. Whereas the second definition is any case of parallelism and ellipsis working together so that a single word governs 2 or more other parts of a sentence. Now, when we say parallelism or ellipsis in poetry, so parallelism, we mean it's based on repetition. So that's pretty much repeating grammatically similar words and phrases. That's what parallelism is. And ellipsis is just the omission of parts of a sentence or phrase. And you'll see with the answers here an example of ellipsis, and I'll show you that in a second. Now, it says, consider the following unrelated figures of speech. You've been given 4 options here. So the first one is Miss Bolo went straight home in a flood of tears and a sedan chair. Second is they covered themselves of dust and glory. Third is lust conquered shame, audacity, fear, madness, reason. And the fourth is ask not what your country can do for you, ask what you can do for your country. Now, these are 4 figures of speech. We've been asked which of these phrases, 1 to 4, are not examples of zeugma. So one of them has to not be, at least one of them isn't an example, because you can see all the options available, at least one of them isn't an example. Now, if we take a look at each, now let's have a look at the first one. So if I just get my pointer out. Okay, so remember, zeugma can be a single word or phrase which joins 2 different parts of a sentence and is differently in relation to each. So let's look at the first one. Miss Bolo went straight home. That's the first part of the sentence. In a flood of tears in a sedan chair. Sounds like it's going to match 1, because you can see here, it's 2 different parts of a sentence and they're joined together. But they're differently related to each. You can see here, just she went home, but at the same time, flood of tears and sedan chair. They're just they're opposite of each other, because you wouldn't expect if someone went home, they're crying in their chair. So you could assume that 1 is definitely going to be a zeugma. 2, they covered themselves with dust and glory. So they covered themselves with dust and glory. So that again is going to satisfy part 1, the number 1 definition. So 2 is also a zeugma. Now, three says lust conquered shame, audacity, fear, madness, reason. Now, if we take a look at the options available, a single word or phrase which joins two different parts of a sentence and must be understood differently in relation to each. Now, if we look at option one, lust conquered shame, audacity, fear, madness, reason, they're all linked. So it's not necessarily definition one. If we take a look at definition two, it says any case of parallelism and ellipsis. So remember, ellipsis, it kind of involves the omission of parts of a sentence or phrase to join two phrases together, so that a single word governs two or more parts of a sentence. So you can see that clearly. So lust conquered. So this word lust is governing because of the ellipsis, or in this instance, the omission of the words to just say as one word each. So lust conquered shame, audacity, fear, madness, reason. So lust is kind of controlling all of this, and we use the ellipsis to bring that about. Also, it is a form of parallelism because what we've done is we've kind of repeated grammatically similar words and phrases. So shame, I mean, they're similar in a way because madness, fear, audacity, shame, reason, they all come under the same umbrella of, let's say, somebody who is lustful, somebody who's doing something that's against the grain, someone who's doing something that's sinful, worrying, stressful. So it's definitely, and pairing the words together is kind of a form of parallelism, and obviously the ellipsis here of breaking up the sentences. And they could have said lust conquered shame. Lust is also defined by somebody who has audacity, somebody who's fearful of the consequences. They must be mad, but they do reason why they're going to do it. But they've shortened it into one simple sentence by using ellipsis here. And I guess the parallelism. So you can argue that 3 is definitely example. So that's example 1, example 2. 4. So, I mean, we know that 4 is definitely the answer, since it's definitely not an example of zeugma. So D is the correct answer. Why? Let's see why. So it says, ask not what your country can do for you, ask what you can do for your country. Now, these two, let's call them phrases, are linked because they both pretty much mean the exact same thing, except they're just flipped. So it's just reverse order. So it says here single word which joins 2 different parts of a sentence. So it's not one. So definitely not one. And 2 says parallelism and ellipsis working together so that a single word governs 2 or more other parts of a sentence. That's not what is happening here. You've got 2 phrases here that mean exactly the same thing, but they're switched. Now, for the keen-eyed GAMSAT sitters, you'd know that this poetic technique, or this literary technique, is called chiasmus. Now, a chiasmus is a rhetorical figure in which the grammatical constructions are repeated in reverse order. So you can see here, ask not what your country can do for you, ask what you can do for your country. So it's the same phrases, but they're just switched. So this is a chiasmus. So as for those who want to look it up. So chiasmus. Now, you might say, how the hell am I supposed to know that? Again, if you had your own document with a summary of, or just some sort of document with different poetic literary devices, let's say it's a zeugma, you can give the definition, then you can give an example, and then you can give how to use it in poetry, or so how to use it in literature. Let's say you pick out 50 different poetic devices or literary terms. So it could be metaphor, simile, it could be say ellipsis, parallelism, it could be apostrophe, it could be what else do we have? There's onomatopoeia. The world is endless. Your list is endless, sorry. So if you just make a list, define the word, give an example of how it's used, and then try to see how you can design your own phrase using it in literature, or try to see if you can read literature and read it. Because sometimes when people are writing, it's not like you purposely write a metaphor. It might just be passive. You accidentally written a metaphor. You read something in the paper and you find out, oh, you know what this technique is? The reason why it's so catchy is because they're using alliteration or consonants, or assonance or whatever it is. So try to be active when you read to find these literary devices. So that's the key here. Now, if you're still struggling with this concept of zeugma, you can comment, let us know. I think if we put it on YouTube or any other social media platform, if you're having problems with these sort of poetic devices, and if you would like more information on how to improve, you can just leave a comment, let us know, and we'll try to help you out, because I know section 1 is notoriously difficult for students to improve in, but I don't think that's because it's impossible to improve your section 1 score. It's definitely possible. I just think it comes down to if you're willing to do the 1%ers. If you're willing to do the 1%ers, you should, in theory, improve your section 1. We can definitely help you with that. Cool. So now on to section 3, chemistry in visual form. What I'll do is I'll let you just have a quick read here. I'm just going to have a quick sip of water. You can pause the screen and then we'll dive into it. This, again, is what I like to call, when I design this question, it's definitely like another, let's say, stereotypical, for those who haven't sat GAMSAT before, a stereotypical GAMSAT question. They give you some sort of figure, they give you an equation or a formula, they give you some sort of stimulus explaining how to manipulate the formula or the figure, and then they're going to give you some questions. I'm just going to have a quick sip of water. You can pause the screen, have a read, and then we can, I can show you the 2 following questions, and then we can address how to answer each question. 1 second. Okay, so hopefully you've had a read. What I'll do is I'll show you the questions now as well. So in section 3, GAMSAT, you're afforded, I think it is, so 75 questions in 150 minutes. So you get pretty much 2 minutes per question. So we've got 2 questions today. So we've got question 1. So you can pause screen here. And question 2. So give yourself about 4 minutes to answer these 2 questions. And then we can go through and answer them together. And I'll just go through so question 1, question 2. And then what I'll do is I'll count down to 5 and then we can go through it together. Okay, great. So this stimulus is telling us that the Hammett constant, so this sigma looking symbol, for a particular C substituent, which we find out later on for ketene imine reactions, is given by the equation. So let's say Hammett constant equals log Kr divided by Kh, where Kr and Kh are the dissociation constants of the substituted and unsubstituted acids, respectively. So this ionization is influenced by electrons. So let's just highlight some things here. So this is definitely important. So we'll go electron withdrawing or donating. So an electron withdrawing substituent will have a positive value. So we'll circle that so you know for electron withdrawing. An electron donating will have a negative value. So you can see here that withdrawing is going to have a positive Hammett constant, and a donating is going to have a negative Hammett constant. I know in the exam, it is an online exam, so circling would be a bit hard, but you do get a piece of paper. So hopefully you can put some sort of symbol to remember straight away that circle here is for positive, a Hammett constitution for withdrawing, electron withdrawing group, and negative is for electron donating group. So the cis-trans ratios, which we see here, of ketone imine reactions correlate well with the Hammett constant and are depicted for W, X, Y, and Z C substituents, well, below or beside. So you can see here the Hammett plot of the reaction between two chemical groups with different C substituents. Now, before we attack the first question, let's just make sure we understand what we're being told here. We're being told that you get there's linear regression, so there's a linear correlation between log cis of trans of ratio of ketone imine reactions to the Hammett constant of these C substituents. So what it's saying is there's a correlation between cis and trans configuration to the electron withdrawing or electron donating capacity of the C substituent. So that's what we're being told. There's some sort of link here between cis and trans and the electron withdrawing and donating capacity of the substituent. So you can see that clearly. So we can make some inferences here. So you can see that we've got 0 over here. So let's just draw a dot. So about 0 over here. And you've got 0 about here. So keep that in mind. You also have, okay. So we'll go on this box here. So when it does hit 0, it's about, let's say, 0.5. So you can see clearly just by eyeing out this, this graph. Remember as well, when we say log cis over trans, it's the same if you use logarithmic rules. It's the same as log cis minus log trans. So it's the same thing here when we look at Hammett constant, log Kr, which is the substituted. So log dissociation constant for the substituted acid divided by the dissociation constant for the unsubstituted acid is the same as log Kr minus, so if you could just write this anyway, log Kr minus log H. So it's the same principle. So keep that in mind. Remember logarithmic rules. So what does it mean? So what we can see here is that we get all the negative values here. So you get negative, so which means if you have a negative log cis trans, if you think about it logically then, it means that for a negative value, you have to have more trans than cis because it's a big negative value. So that means if you're going to have anything in this region here, so they're all negative values. So anything in this region here is going to be majority trans. So we're just looking at, keep in mind, this is just the y-axis. We haven't talked about the electron withdrawing or donating group yet. So most of the substituents in this region are going to be majority trans because we can see it's a negative log cis on trans value. And we know that the higher the trans value, it means it's going to be a bigger negative number, which means we're going to be in this region here. If we had a big cis value, let's say a massive cis, we'd be above here. So that means this region here is cis. This is going to be trans. And the reason why I left this blank is because it's going to dictate whether it's going to be electron donating or withdrawing. But you can see here that anything below, so we get electron donating. So you've got donating and withdrawing. Okay, so for mixtures with, so I wrote this down so I don't confuse myself here. For mixtures with electron withdrawing, so positive, the product is predominantly cis. Yep. So you can see it's going to be cis, so above this region, if is greater than 0.5. So you can see this region here, they're going to be predominantly cis. You might get cis in this region, but you can see clearly, so it's this region up here, sorry. So this is going to be cis, generally. Majority cis. So in this region up here, whereas that's if the product is predominantly cis. For mixtures with electron donating groups, so this is withdrawing groups. So for electron donating groups, that's a negative, so negative Hammett constant. The product is predominantly trans. So you're mostly going to get trans here. So this is mostly going to be trans. This is mostly going to be cis. In this region here, they're generally majority going to be trans, but you're going to get a fair number of cis here. So let's say this is going to be trans plus plus plus. This is going to be trans plus plus, so not much. It's going to be much more because it's negative value. Over here is going to be cis plus plus plus. And then you can see here in this region, because it is going to be obviously electron withdrawing, you're going to have majority trans in this region here. So there's different regions to this figure, to this graph. So just try to envision what's happening here, what it's telling you. So just keep in mind that when we go through the next couple of questions. So there's different regions on the graph in terms of, well, if you have large cis, because you're looking at two variables here, I might just get my pen out again. It'll make much more sense when we go through the answers together. Okay. So remember, if we have a great amount of cis, it means that we're going to be in the positive, because a large cis, a large number minus a small number, is going to be a positive value, right? So we're going to be up here in this range. That's if we have cis. But if it's going to be cis electron withdrawing or electron donating, it depends on what's happening here. Generally speaking, most of the cis, it looks like, are going to be electron, so from this region here, right? They're going to be electron where is it? Positive value electron withdrawing. So they're going to be electron withdrawing. Whereas if you come down to this region here, you can see that you're going to get a majority trans for these guys here, but this region is going to be, so we can say this is, I'll write it again, cis electron withdrawing, so we call it W. This is going to be cis, sorry, this is going to be trans. We'll say this is trans electron withdrawing. This is going to be, this region here is going to be, because it's all negative, and over here is all negative, it's going to be trans donating, so we'll call it D. So cis W, trans W, so for this region here, this is going to be so positive, negative, so this is going to be, again, trans withdrawing. So there's going to be trans withdrawing, that's cis withdrawing. You can see the populations we have now. So for that region, so this is this region here. And this region, you can see it's going to be, well, this region, you might have to cut it into 2 again. So it's 2. So this is going to be positive. So it's going to be cis, and it's positive. So it's going to be withdrawing. And this is going to be cis, negative. So it's going to be donating. So D. Yes. So you can see how we've created now all these different profiles on the graph. So that's going to probably make it easier than what I did before. So let's dive into the first question. By the way, if you're having difficulty trying to understand why, you can just leave a comment below and we can discuss how we can move forward with how to understand. But again, because you have 2 variables, you have to understand it's kind of like a puzzle, kind of like a little game, which is kind of fun. So these are the sorts of questions in the GAMSAT that ASA loves doing. When I found this graph in some random chemistry paper from like 30, 40 years ago. So I can't remember which paper it was, not this specifically, but it was adapted from a very, 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 very old experiment, which is because it gave a nice, neat linear line. But ASA will give you something similar. So the first question says, you should straight away know P. When we say, so the pKh of an unsubstituted acid is 3, its substituted equivalent possesses strong electron withdrawing properties. So let's see. So the pKh, again, let's circle. And this electron withdrawing properties for that one. Okay. So remember, whenever we put P in front of anything, P just means negative log. Whenever you see P in front of anything, the reason why we do it is because it makes numbers easy to read and it's easier to work with in terms of logarithmic scales. So for example, you've got pH equals negative log hydrogen ion concentration. You've got POH, negative log OH concentration. You've got log P. You've probably seen, for lipid density and lipid profiles, they use the P as well. They use log P, actually. They do use log P. There's a lot of other examples where they use P. So you've got pKa, it's just negative log dissociation constant. So that's all it is, the concentration of Ka. So same principle here. If we're saying pKh, it's just saying negative log. So pKh is the same as negative log concentration of Kh. Now remember the equation which we have up here. So keep that in mind. So we have here the Hammett constant is equal to log Kr minus log H. So let's just convert this to our log H, because it's log Kh, sorry. Our log Kh, because it's just easier to work with in terms of the equation. So remember with logarithmic scale, so we'll assume this is log base 10. We've been told that the pKh equals 3. If we want to get rid of log, we just have to do to the power of base 10. So that's all you have to do for log 10, right? So all you're going to do to convert this back into Kh, so it's going to be to the power of 10. So to the power of 10 to get, and you've got a negative, so it's going to be negative. So 10 to the power of negative to get rid of this, so that crosses off. And then you end up with 3. So 3 equals Kh. So your answer, therefore, so you know that Kh, therefore, is 0.001, right? Or 10 to the power of 3. Or you could just say, or 1 by 10 to the power of negative 3. So that's your, we haven't done anything. All we've done is just converted pKa to the actual value. So, well, in this instance, it's going to be the acid proton concentration or whatever it is. It's going to be 0.001. So whatever that concentration is, if it's molar or whatever, let's just forget the concentration units, but let's just say the answer is going to be 0.001. We haven't done anything. We've just, not this answer here. We've just, sorry, the conversion is 0.001. So if you're told that you have pKh of 3, the KH is just, I guess, the log reciprocal, which is 0.001. So we've got that out of the way. But the question is asking, the pKh of an unsubstituted acid is 3. Its substituted equivalent possesses strong electron withdrawing properties. Remember, electron withdrawing has a positive value, so a positive Hammett constant. So if we go here, so log equals, so the log Kr, which is what we're looking for, so let's just say Kr minus, we've got here, let's say our log 0.001. But you can see the idea here is, if it has electron withdrawing properties, Kr, it means it has to have a positive Hammett constant. So to have a positive Hammett constant, this has to be, so log Kr has to be a greater value than 0.001, because if it's less, you're going to get a negative Hammett constant. So if you have a billion here, negative minus this, you're going to have a positive value. So anything greater than 1 by 10 to the negative 3 is going to give you a positive Hammett constant, which means it's going to give you a Kr. So that means the Kr is going to, so it's electron withdrawing substituent, right? So you have to have a positive group, so a positive Kr. So you're going to see that your answer is going to be B. Simple math, it's just converting and making sure you understand that for this to be positive, this has to be well higher than this number. So that's why it's greater than 1 by 10 to the negative 3, because it gives us a positive value. You can try it with your calculator, but it's not necessary. It's just, it should be common sense. It should be you should deduce this from prior mathematical knowledge. So that's how we address this question. Now, the next question. Which C substituent is most likely to produce a quasi-equal split of cis and trans products? Now, when we say quasi-equal means it's something that resembles, but it just isn't. So quasi-equal means it's something that it's probably going to be an equal split. So it's something that looks like an equal split of cis and trans products. Now, if you take a quick look at this figure here, you can pause the screen or come back, but it kind of comes into what we explained at the beginning. Remember, log cis over trans is the same as log cis minus log trans. So it makes sense, if you're going to get an equal split of cis and trans, you want, so that's, I guess, 50-50. So 50-50. So 50-50 equal split. You can see here, to get 0 on this, on the y-axis, it means that log cis and log trans have to be equal. So that means, for example, 1 minus 1 equals 0. You can have 2 minus 2 equals 0. A million minus a million equals 0. So the point is, in order to have an equal split, your this has to equal 0, because you have to have equal log, equal cis, equal trans, so that it can equal 0. So think about it. So cis equals 1, trans equals 1, which means you're going to end up with 1 minus 1 is 0, or log 1, which is 0 minus 0, log 2, which is the same idea. So in order to have 50-50 split, so 50-50 split, we have to have y. So y is the only one that kind of fits a quasi-equal split. So what this means is, so the C substituent y is going to, if you substitute this in a ketene-amine reaction, you're going to have equal numbers of cis and trans. And when we have equal numbers of cis and trans, if you put them into the equation, you're going to end up with the value 0, which means you've got 50% cis and 50% trans. So hopefully you understand is just, again, utilizing log laws, log rules, and understanding that in order to get 0, you just have to have equal amounts, which is 50-50. So there's a 50% here equals minus that equals 0. So that's why the answer here is y. Now, just keep in mind that means, remember what we said earlier, y is probably, well, most likely going to have, we'll say it's going to be about equal, but it's probably going to be just a bit more trans than cis. So it's probably just going to be a bit more trans. But let's just say it's equal because it's quasi-equal. So let's say equal. So y has, if you use the y substituent, you're going to afford a molecule in the immune ketone reaction, which is going to give you a split of cis and trans, but y is a electron. We've got it here, withdrawing positive. So it's going to be a positive, generally speaking, it's going to be a positive Hanna constant. But that's the idea. But again, look, they're very small anyway. So you'd have to do the empirical tests. So in the lab work, to get the exact ratio, but that's the point. So that's why the answer here is C. So I think that concludes. Yep, so these were just to go through the questions together. So yep, that does conclude the 2 questions and this section. I think the important thing with this, I think it's the most important, is to draw something like this. I know in a GAMSAT you don't have much time to do something like this, but I mean in practice, whenever you're looking at graphs in practice, try to be as active as possible whenever you analyze a graph. Don't just look at it and be like, okay, here's my line, move on. Analyze all the different regions in the graph. Analyze all the correlations. Analyze what it means if there is this linear correlation between the X and Y axis. What does this mean? You know, with linear regression, you know, you should have learned this hopefully in first year of university, but just brush up on it as well. And just try to find other populations that I might have missed or probably incorrectly done in haste. But the idea is just try to look at the graphs, be proactive, active in your study when you're looking at figures, because they all try to look, because all ACER questions for GAMSAT are similar. They have some sort of trick in them where you have to kind of look for solve the puzzle. So that's what's happening here. You're solving a puzzle. So keep that in mind. So just to finish off, if you do have any further questions about this topic, so chemistry and visual form, or if you would like to point out other questions you've had difficulty in the past, please contact me. Put questions down in the comment section below. We can go through them together. I mean, if you do have any difficult questions, you can always shoot them through to me. We can work through them together. I know, I mean, if you do join our programs, our GAMSAT Premier program or Foundations or Essentials, we can definitely help you there with the questions. But if it's a general question, I can definitely answer that for you, especially in the comment section. So that's it for today. Our next session is going to be on the 18th of May. It's going to be a similar format, similar structure. It's going to be about a couple of weeks just before your submission. So GAMSAT applications submissions are 31st of May. Please keep that in mind for the GAMSAT schools, so the 10 GAMSAT schools. I think UCID and so I think UCID's a bit earlier for dentistry and for medicine. And I think Flinders, yeah, May 31 is when they open. They release the admissions guidelines. So it's gonna be, I think we're gonna go through poetry in that webinar. And what did I put together for section 3? I think I put together what was it? Was it chemistry, biology, physics? Oh, I can't remember now, but we'll find out eventually. I'll send you an email anyway with the details. Don't forget, you can go on our website to access the cheat sheets for entry and medicine admissions for 2024. And if you do have any questions, you can contact us for a free consult. Have a fantastic weekend, Eid, holiday period and mid-sem break and exam period, and we'll touch base soon. Take care. Bye now.